Welcome back to Topics in Statics. We're up to the method of sections. The method of sections is another method we use to analyze a truss. The basic idea is if the entire truss is in equilibrium, then any segment of the truss I want to look at also has to be in equilibrium. So what we're going to imagine doing is we're going to imagine slicing through the truss and looking at maybe this half of the truss or that half of the truss. We're going to cut it in half. So the question we need to answer first of all is, what happens if I slice through a member that's in tension or a member in compression? Well, if I slice through this member in tension, as shown in this picture, I expose a new force, which is also pulling on that beam. Any force I expose by cutting through the middle of it also has to be pulling on it. Same thing in compression, it also has to be compressing. So we're still doing planar trusses, so we've got planar equilibrium, which means I've only got three equations. Sum of the forces x, sum of the forces y, sum of the moments. Or a lot of times with the method of sections, I use one force equation and two moment equations, but we'll see that when we work the problems. Again, I have to worry about the sense of the forces. I try and determine them, but sometimes I can't, in which case I just draw them in tension, and then if they show up as negative, I know that it's actually in compression. How do I know where to section the truss? Usually in the problem, it gives me a pretty good idea where to section it. I'm going to cut to expose forces that I'm interested in finding for the solution to the problem. The big concern, though, is that I've only got three equations of equilibrium, so I don't want to expose more than three unknown forces. So let's work an example. It'll make more sense then. So given the loaded truss as shown, find the force in members Kj, Kd, and Cd. Well, I want to find the force in those three members. So where are those three members? Let's put a red dot on those three members. Kj, Kd, and Cd. So what would happen if I slice through this thing right along here? I would expose those three members, and then I can calculate with them. I can apply the equations of equilibrium either to the left side or the right side. Right? Imagine I'm going to cut it. And I'm just going to draw a free body diagram of the left side or the right side. Now, whichever side I choose to analyze, I need to know what the support reactions are. So let's start there. We need to know the support reactions. In fact, let's figure out which side we're going to do. Let's analyze the left side. Right, so when I do the sectioning, I'm going to analyze the left side. So I need to know the support reactions at A. So to find the support reactions, I draw a free body diagram of the entire truss. Here's the entire truss. It's got three loads applied to it. And then over here on the left, it's going to have a y component and an x component. And on the right-hand side, it's going to have, and that's the free body diagram of the entire truss. I can make a list over here. This one's 20 kilonewtons. This one's 30 kilonewtons. And this one's 40 kilonewtons. So if I want to find AX and AY, what I would do first is do the sum of the forces X. That has to be equal to 0, and that tells me that AX equals 0. Nothing to. Now we're going to do, I want to find AY, so I'm going to do the sum of the moments about G. has to be equal to 0. So the moment's about G. I'm going to choose positive to be counterclockwise. So that means I get FB times, how far is that? 2, 4, 6, 8, 10 meters. Plus FC times, that's 8 meters. Plus FD times 6 meters. And then minus AY times 12 meters. And that has to be equal to 0. I solve for AY. And I find that AY is 56.7 kilonewtons. So far, so good. So now let's talk about sectioning. Remember, we're going to section this truss right here. And we're going to analyze the left-hand side. So I'm going to draw a free body diagram for that left-hand side. Now, what forces are acting on this thing? The only forces I've got acting, I've got AY acting there. I've got FB acting here, FC acting here, and I've exposed 3 forces in the middle of beams. So I'm just going to draw, I'm going to make them all point out. I'm not going to try and determine the sense, I'm going to make them all point out. So this is KJ. This is K. Whew. Let's try that again. This is FKD, and this is FCD. Now, if you want, I could draw the rest of the truss in here. It may make it easier to see what I've got. So step 1, what am I going to do? Let's calculate moments about point D. Why am I going to choose point D? Right, look at where D is. I'm going to do the sum of the moments about D is equal to 0. The reason I chose D is that 2 of these forces, these unknown forces, pass through D. FKD and FCD both pass through that joint. Therefore, they don't produce a moment about it. So again, I'm going to choose counterclockwise to be positive. So I get FB. How far is FB from D? That's 4 meters. Plus FC times 2 meters. Those are both making it rotate counterclockwise. Then AY is going to make it rotate clockwise, which it's a distance of 6 meters. And then finally KJ, which is a distance 3 meters. And all that has to be equal to 0. So now we solve for KJ. We find it's minus 66.7 kilonewtons, or 66.7 kilonewtons, and it's in compression. And it's in compression because I got that negative number there. So now I use sum of the forces in the y direction has to be equal to 0. So what is that? That's going to give me AY minus FB minus FC minus, and now it makes more sense to draw a triangle here. Here's my triangle. This is 2, this is 3, so this other side is 9 and 4 square root of 13. So the y component of this is going to be 3 over the square root of 13 times f kd. And that has to be equal to 0. Solving for FKD, I get 8.05 kilonewtons. Because that's positive, that means it's in tension. And last but not least, I do the sum of the forces, X so I get minus 66.7 kilonewtons. Well, let me back up. So sum of the forces in the X direction, so I'm going to use KJ. KJ points to the left, so I get minus KJ. I get plus 2 over the square root of 13 KD, FKD, plus FCD equals 0. And from that I get FCD is 62.2 kilonewtons tension. And that's how you work method of sections. Next time we'll talk about frames and machines.